Niels Bohr's model of atom. See, after understanding the nature of the EM radiations, the photoelectric effect, the dual behavior, and after doing all the previous models, let us move to the one which is the most accepted model of the atomic structure. Niels Bohr was the one who actually has given the model which was not only being accepted because of the energy, the radius and the velocities etc. which are associated with the electron he has given. But the most important fact which makes this Niels Bohr model most successful is that he was the first one who explained the hydrogen atomic spectra. He explained the reason why the line spectra originates, how it originates, and that is why this is regarded as one of the most successful models we have. He also tried to explain the atomic structure in such a simplified way with all the related physics phenomena. That is why it still uses it to explain the basics of the atomic structure. The benefit which the Niels Bohr got, that since he has worked with the J.J. Thomsons and Rutherford, so whatever the mistakes which these two have done earlier with their atomic models, all those were taken care by the Niels Bohr, and he incorporated all those all those things which they have achieved, they have discovered. Along with he incorporated all the postulates of the Planck's quantum theory of EM radiations, and then he came out with his own model of atom. So first thing which is to be remembered is that the Niels Bohr's model of atom is based on the Planck's quantum theory of EM radiation. Then let us do the postulates of the Niels Bohr's model of atom. Now the first postulate is that according to the Niels Bohr, that the hydrogen atom or the atoms are again spherical in shape, whole of their mass and positive charge is concentrated in a very small space which is called again nucleus, and the electrons are present. This is what the atom is, and the electrons are present around these nucleus in the circular paths which are called orbits. Now he was the first one who said these electrons are present around the nucleus in these circular paths called orbits, which are having certain fixed radius and energy. The biggest advantage of the Niels Bohr's model is that he was the first one who used the word quantized. He said that around the nucleus there can be infinite number of paths in which paths are there, which are called orbits. But electrons are present or will be present or will be existing only in those orbits or those paths in which they will be having certain fixed quantized energy and as well as certain fixed angular momentum. So he gave us the first time the conditions for an electron to exist around the nucleus in these paths. I am repeating again, there can be infinite number of these paths called orbits around the nucleus, but the electrons will be existing only in those orbits in which its energy is quantized fixed and its angular momentum is also its integral multiple of some number. So that is the one biggest advantage, that he used the systems or the word quantized into this phenomenon, because he was knowing that he has to prove what the line spectra which works on a quantized principle which has been obtained from the Planck's quantum theory. So the first postulate is atoms are spherical, whole of the mass and the positive charge concentrated to a very small space called nucleus, and electrons are present around the nucleus in the circular paths which are having fixed radius and energy called orbits. Now what he said, that these electrons are associated with a certain fixed energy, and that energy is energy of the electron in any orbit is minus 1312, it's kilojoules per mole. Per mole, we can write it like 1312, or for any particular orbit it can be written as 1312 n square over z square. It can be written as 1312 z square over n square kilojoule per mole. So this is what is the formula of finding out the energy, or it is the formula which tells us that the energy is associated with the electrons in any particular orbit, and n square is the orbit number. They said the orbits around the nucleus can be 1, 2, 3, 4 like this, they can be numbered. Later on these orbits or these number are given a symbol n, which is also called principal quantum number. So this n is your principal quantum number, z is your atomic number. So this is how we said. What is the most biggest thing is that with the use of this formula we can find out that as we keep on moving away from the nucleus, the energy of the electrons associated with the particular orbits goes on increasing. Now before moving further, we need to understand here only that why the energy of the electron is given, this is z square over n square kilojoules per mole. Why this energy of the electron is given a negative sign? How can energy be in the negative state? See, this is very simple. It is believed, see, if an electron is existing at infinity, its energy cannot be determined. So we think that its energy, or we take its energy to be 0. So the electron's energy at infinity is taken or is considered as 0. It is considered as 0, since numerically we cannot find out its exact value. Now, when this electron is being attracted and retained by the atom inside its own system, by the nucleus of this atom is attracting this electron and retaining it in its system, what we find is this electron has to do certain work, and as a result some of its energy gets consumed. That is why the moment it reaches to this value, or this reaches to the near to the nucleus, its energy becomes what? Negative. Now more closer it goes to the nucleus, the more negative its energy becomes, or lesser the value of the energy becomes. That is why what we find is that the energy associated with the first orbit with the electron will be how much? 1312. I am talking about in case of hydrogen atom, it will be 1 square. Similarly, energy associated with the second orbit will be 1312 by 4, because 2 square means 4. This is in the second orbit. And similarly, the energy associated with the third orbit will be 1312 upon 9, and it will be as energy associated with the third orbit. Now, if you divide the same number by 4 over 9, we think that the number becomes smaller, but since these signs are negative, what we find is the most important thing, the striking thing is this, that it means the energy of the first orbit is minimum, the second is having higher than the first one, and the third one is having higher than the second one, and so on. So as we move away from the nucleus, the energy associated with these orbits keep on increasing. That's the most biggest advantage of this model is. The next postulate, the third one, according to the Niels Bohr, electrons doesn't emit or lose any radiation, any energy until and unless they are in this same orbit. Electrons doesn't lose any energy until and unless they are in the same orbit. Now, when they lose energy, they lose energy only when they get excited to higher energy level. They cannot stay there for a longer time, and they comes back, and the difference amount of energy is given out or is actually emitted out in the form of radiations. So whenever the electron is showing any kind of transitions, then only the energies are given out. Otherwise, unless it is in its own same orbit, it is not going to emit any, or it is not going to lose any energy. So it's not going to emit any radiation. So radiations are emitted out only during transitions. That's the most important thing. The fourth postulate is very much associated with the same thing. Suppose we have a hydrogen system. This is the first orbit, this is the second orbit, this is the third orbit, this is the fourth orbit, this is the fifth orbit. Now the electron from the first orbit gets excited, because in order to excite it, in order to make this electron move to the higher energy level, we have to definitely increase its energy. So we give energy to this electron in the form of EM radiations or heat. It gets excited to the third excited to third energy level. Then it comes back immediately because that will make the system's energy higher. So in order to reach to again the more stable system, the system loses energy, so the electrons of this particular system again comes back to its original state. Now, when they are coming back again to the ground state, which is the first orbit, the difference amount of energy is given out in the form of EM radiations. Now, you need to know, this is what is the fourth postulate is, that the energy which is given out, the energy difference which is given out by the when the electron is making transition from a higher energy level to low energy level is equal to energy associated with the electron in the N2 level to energy in the N1 level. You need to understand what is this N2 is higher energy level and N1 is lower energy level. So only then when these transitions are done, the difference amount of energy is given out in the form of radiations. So N2 is always higher energy level, N1 is your lower energy level. Now after understanding that the amount of energy released whenever the electron is making transition from any higher energy level to lower energy level is equal to the difference of the energies of the two energy levels. So if an electron is making a transition from N2 level to N1 level, the energy difference is En2 minus En1. Now, what we do is, this energy difference, delta E, which is En2 minus En1, is given out in the form of what? H nu, the EM radiations, or which can be written as Hc over lambda. So we can find out, if we know this delta E, the difference amount of energy, then we can find out the wavelength or the frequency of the radiation which is given out by the EM radiations. What we do is, we simplify this formula into a much simpler form, and we write write this formula, which is actually is En2 minus En1 as Hc over lambda. And what we do is, if we have to find out what the wavelength, we can write it as Hc over lambda. It will be equal to what? Minus 1312 your z square over N2 square minus of 1312 z square N1 square. When we solve this, we take out z square, n square as such are written, 1312 and z square are taken out common. Hc z is taken out as like this. We can take it as, like you can see, it will become 1312 upon Hc. This will become what? 1 upon N1 square minus 1 upon N2 square. Z square is taken out here. When we solve this value, what we can get is, we also know 1 by wavelength is your wave number. This term is your wave number. So this wave number becomes equal to what? This whole term becomes, when it is converted from mole, it becomes 109,677 1 upon N1 square minus 1 upon N2 square Z square. It is in per centimeter, because wave numbers unit is per meter or per centimeter. What is important to note is, in this way, if we have to remember only just one constant. This 109,677 is called RH. It's called Rydberg constant, and whose value is 109,677 per centimeter. So in place of remembering the value of H and C and different things, we can directly find out the wave number. Once we know the wave number, we can find out the lambda, or once we know the lambda, we can find out the energy differences. So the actual formula which can be written, the most simplest form is that the wave number is Rydberg's constant 1 upon first energy level, lower energy level to the higher energy level, and this is Z square. Z square again is the square of the atomic number of the species in which the excitation of the electrons are done. So this was your postulate basic, which is talking about when an energy is being released. Next postulate. I think this formula is clear. The next postulate talks about its angular momentum. As I told you from the fifth postulate is, Niels Bohr said that for an electron to be in any particular fixed orbit, it must have a fixed angular momentum. So an electron is associated with a fixed angular momentum, which you will learn more in your physics, that whenever a particle is moving in a circular path, it always gets accelerated and it develops angular momentum, since its direction are getting changed every time. Now, the electrons are associated with the fixed angular momentum, and this is always integral multiple of h over 2 pi value. And we know angular momentum is always mvr, so it will be equal to integral multiple of h over 2 pi. N is your any integral multiple value. So this is what is the formula is. He said for an electron to be any fixed orbit, it must have a fixed or angular momentum, which is always an integral multiple of h over 2 pi value. So n is the any numbers like 1, 2, 3, 4, 5, h is the 2 pi, the multiple of this, and mvr, m is the mass of the electron, v is the velocity of the electron, r is the radius of the orbit in which it is existing. So this mvr, angular momentum, is equal to integral multiple of h over 2 pi. So this is again second condition. The two conditions which I have discussed is, first the energy, which I have given you the formula, and the second is the angular momentum. So for an electron to be in any particular orbit around the nucleus, Bohr gave two conditions. First is of an energy, which was already given, and the second was angular momentum, which should be integral multiple of h over 2 pi values. So this is what the most important thing is. The next postulate, since we now know what exactly how these mass, velocity and radius are related, we can find out the velocities and the radius of the orbits. The next postulate talks about this, that the velocity of electron in an orbit is given as, we say, velocity of electron, it is given as 2.18 into 10 to the power 6 meters per second. I am talking about, this is the velocity of an electron in the first Bohr orbit in case of hydrogen atom. It is always, if we go by the exact formula, it is 2.18 into 10 to the power 6 z by n meters per second. Z is again is your atomic number and n is your principal quantum number, whose values are 1, 2, 3, 4, 5. So what we find is, as we move away from the nucleus, as the value of the n increases, the velocity of the electron will keep on decreasing. This value is also very big. Remember, the speed of the light is 3 into 10 to the power 8 meters per second, whereas the velocity of the electron in the first Bohr orbit is 2.18 into 10 to the power 6 meters per second. That's the most important thing. So the sixth postulate talks about the velocity of the electron in the orbit, and the seventh one talks about the radius of the orbit. The radius of the nth orbit, we call it Rn, is given as 0.529 n square over z Armstrong's unit. It means 10 to the power minus 10 meters. So this is again is a very valuable information. The radius is 0.529 of n square over z. So this shows that the moment we are going away from the nucleus, like we are into the second orbit, this number is multiplied by 4. We are into the third orbit, this number is multiplied by 9. So it means the radius keep on increasing as obvious as we are moving away from the nucleus. So this is again the most important postulate we have from Niels Bohr's model.